There is a stone sitting in a hillside in Lebanon right now, today, that weighs more than a fully loaded Boeing 747 15 times over. It is not standing upright in a temple. It is not on display behind glass. It is still half buried in the bedrock, where it was cut nearly 2,000 years ago, and no machine that exists anywhere on Earth today could pick it up in one piece. That single fact has fueled 100 documentaries, 1,000 YouTube thumbnails, and one persistent question that refuses to go away: if no crane built by modern humans can lift this thing, how did anyone move stones like it in the ancient world at all? The honest answer is stranger and more impressive than any theory involving lost civilizations or visitors from beyond the sky, and by the end of this video you will understand exactly why. The site is called Baalbek, tucked into the Bekaa Valley of eastern Lebanon, roughly 85 kilometers northeast of Beirut, sitting at an elevation of around 1,150 meters. Today it looks like a ruin, and in a very real sense it is one. Earthquakes have knocked down most of what once stood there. Later builders picked the site apart for centuries, hauling away smaller stones to use in other buildings. The location was abandoned, reoccupied, abandoned again, and then rediscovered in the modern sense by a German archaeological expedition that worked the site from 1898 to 1903 under the sponsorship of Kaiser Wilhelm II. In 1984, UNESCO placed Baalbek on the World Heritage List, recognizing it as one of the finest examples of Roman temple architecture anywhere in the world. What survives is still staggering. 6 Corinthian columns still stand from the Temple of Jupiter, out of an original 54 that once ringed the structure. Each of those 6 columns is about 20 meters tall and over 2 meters wide, making them some of the largest Corinthian columns ever raised anywhere in the Roman Empire. But the columns are not actually the most remarkable part of Baalbek. The real story is underneath them, in the platform the temple was built on top of. That platform, or podium, incorporates megalithic limestone blocks on a scale that has no true equivalent anywhere else in the ancient world. 3 of these blocks, set side by side in the western retaining wall of the podium, are known together as the trilithon. Each one measures close to 19 meters long, over 4 meters tall, and roughly 3.5 meters deep. Each stone weighs somewhere between 750 and 800 metric tons. To put that in perspective, that is close to 1.7 million pounds of solid limestone, and these 3 stones are not lying flat on the ground somewhere. They are set into the podium wall about 7 meters above ground level, roughly the height of a second-story window on a modern building. The quarry that produced these stones sits about 800 meters southwest of the temple, on slightly lower ground. That means whoever moved these blocks had to drag them uphill, across nearly a kilometer of uneven mountain terrain, using nothing but the tools and techniques available in the 1st or 2nd century of the Common Era. And here is where the story gets even more remarkable, because the builders of Baalbek did not stop at 800 tons. Still sitting in that quarry today, still partially attached to the natural bedrock, are 3 more blocks that were never finished, never moved, and never installed. The smallest of the 3 is known as Hajar el-Hibla, the stone of the pregnant woman, and it weighs approximately 1,000 metric tons. A second stone, identified in the 1990s, weighs around 1,242 metric tons. And then in 2014, a joint German and Lebanese archaeological team uncovered a 3rd stone at the same quarry, one that had never been documented before. This one weighs an estimated 1,650 metric tons, close to 3.6 million pounds, making it one of the single largest carved stones ever produced by human beings in all of recorded history. This is the stone people mean when they say no human can lift it, and in a literal sense, they are right. No person, and no machine currently manufactured anywhere on the planet, could lift that block as a single unit. The largest mobile crane in the world today, a machine built by the German company Liebherr, tops out at a lift capacity of around 1,200 metric tons under ideal short-radius conditions. The Baalbek stone exceeds that by more than 400 tons. Moving it today would require multiple cranes working in careful coordination, custom gantry systems, or engineering solutions that go well beyond standard industrial practice. So when people ask how the Romans could possibly have moved something like this, they are asking a completely legitimate question. The mistake is in where that question leads them next. For decades, popular treatments of Baalbek have leaned toward explanations involving vanished pre-Roman civilizations or extraterrestrial visitors, the idea being that ordinary ancient humans simply could not have accomplished something on this scale. It is an appealing story. It is also not what the evidence shows, and the evidence at Baalbek is unusually good. This is not a site where we are left guessing at who built it or when. Archaeological excavation beneath the Temple of Jupiter has revealed settlement layers going back to the early Bronze Age, roughly 2900 to 2300 BCE, with continued activity through the Middle Bronze Age as well. Long before the Romans ever arrived, this valley was sacred ground to the Canaanite and Phoenician peoples of the region, home to the worship of Baal, the storm and fertility god whose name the site still carries. Baalbek, in its original form, essentially means the Lord Baal of the Bekaa. Everything changed when the Roman general Pompey conquered the Levant in 64 BCE, bringing the region under Roman administration. A few decades later, Emperor Augustus elevated Baalbek to the status of a Roman colony, giving it the formal Latin name Colonia Julia Augusta Felix Heliopolis. The Greek portion of that name, Heliopolis, means city of the sun, reflecting the common Roman and Greek habit of merging local deities with their own gods. In this case, the local god Baal was equated with the Roman Jupiter, and the massive temple complex that eventually rose at the site was dedicated to a fused pantheon sometimes called the Heliopolitan Triad, combining Roman Jupiter, Venus, and Mercury with the older local figures of Baal, Astarte, and Adonis. This kind of religious blending was a deliberate and well-documented political tool the Romans used across their eastern provinces, a way to fold local populations into the imperial order without forcing them to abandon their own traditions outright. It may also explain part of the genuine mystery surrounding this site, which is not how it was built, but why the Romans chose to invest such an extraordinary level of engineering effort in this particular remote valley. Baalbek was not sitting on a major trade route. It did not control any obviously vital strategic territory. The most widely accepted explanation among historians is that its long-standing sacred status made it uniquely valuable for exactly the kind of religious and political statement the empire wanted to make in its eastern territories. Construction proceeded across roughly 2 centuries, beginning under Augustus around 30 BCE and continuing through the reigns of Nero, Domitian, and Trajan, before reaching its most intensive phase under Emperor Antoninus Pius, who ruled from 138 to 161 CE. It was during this extended building program that the trilithon and the surrounding megalithic podium stones were set into place. This is not speculation or reconstruction from indirect clues. The construction phases are documented. The dedication is inscribed in stone. The colony's founding is recorded in the historical record. The work was Roman, carried out by Roman engineering teams using Roman methods, and the clearest proof of exactly how they did it is sitting in the quarry itself. Every one of the abandoned megalithic blocks at the Baalbek quarry, including the massive 1,650-ton stone found in 2014, bears clearly visible tool marks. These are not ambiguous or mysterious markings. They match a well-documented Roman quarrying technique found at sites stretching from Spain to Syria to North Africa. Workers cut a channel around the perimeter of the intended block, wide enough for a person to stand inside and continue chiseling downward. Once the channel reached sufficient depth, they drove wooden wedges into evenly spaced slots along the base of the stone and soaked the wood with water. As the wood absorbed the moisture, it expanded, and the force generated by that expansion, applied simultaneously at multiple points, cracked the stone free along a controlled fracture line. This was standard Roman practice, used across the empire on projects of every scale, From small architectural blocks up to the largest monolithic columns and obelisks the Romans ever produced. The wedge slots at Baalbek are still visible today. The chisel marks along the channel walls are still visible today. The iron tool wear patterns match Roman metallurgy of the period precisely. A joint research project between the Lebanese University and the German Archaeological Institute, active since 2004, has documented all of this in exhaustive detail, and the conclusion is unambiguous. These stones were quarried by Roman methods, on a Roman timeline, by Roman hands. So if the who and the when are settled, where does the real mystery live? It lives in the how, specifically in two engineering problems that remain genuinely difficult to fully reconstruct even with everything we know today. The first is transport. Moving an 800-ton stone 800 meters, including some uphill grade, using only log rollers, wooden sledges, rope, capstans, and lever systems, sits at the very outer edge of what such simple technology can plausibly achieve. Engineering estimates, based on Roman transport methods and smaller-scale experimental archaeology, suggest that moving a single trilithon block would have required somewhere between 2,000 and 5,000 workers pulling in careful coordination, along with additional capstan and pulley systems to handle the uphill sections. The road surface itself would have needed serious preparation, likely a compacted or stone-laid track, possibly with wetted or greased rollers to cut down on friction. The entire operation would have taken weeks, and simply feeding, housing, and organizing thousands of workers for that length of time was a massive undertaking in its own right. None of this was beyond Roman capability. The empire routinely mobilized labor forces in the thousands and tens of thousands for roads, ports, and public works, using a mix of slave labor, military engineering corps, and provincial labor obligations. What has not yet happened is a full-scale modern experimental replication of the exact operation, moving an 800-ton block 800 meters over similar terrain. Smaller stones have been moved using these documented techniques. Extremely large stones, like the unfinished obelisk at Aswan in Egypt, have been studied in detail as engineering problems. But nobody has yet run the full Baalbek scenario from start to finish, which means real uncertainty remains about the specific details, exactly how the road was prepared, exactly what gearing multiplied the human force on the inclines, exactly how the rollers held up under that kind of load. The second unresolved problem is lifting. Once a trilithon block reached the temple site, it still had to be raised from ground level up to that 7-meter platform. The Romans had genuinely sophisticated lifting technology for their time, compound pulley systems known as the trispastos and pentaspastos, built on mechanical principles described by the architect Vitruvius and the mathematician Hero of Alexandria, along with a larger system called the polyspastos that could combine multiple pulley sets for the heaviest lifts. These systems are well documented and were used across the empire for major construction projects, but the largest confirmed Roman lifts elsewhere come close to the trilithon scale without quite matching it. The leading theory is that temporary earthen ramps were built at the site, with the stones hauled up the ramps using the same capstan and roller systems used for the horizontal journey, and then the ramps dismantled once construction was finished. There is some physical evidence at the site consistent with temporary earthworks from the construction period, but there is not yet a single definitive reconstruction that experts universally agree on. And this brings us back to the largest stone of all, the 1,650-ton block still sitting in the quarry. If the 800-ton trilithon stones were already pushing Roman engineering to its limits, a stone twice that size would have been operating in an entirely different category. The fact that this stone, along with its two smaller, but still enormous companions, was never moved suggests these blocks may represent the actual ceiling of what the engineering teams at Baalbek could realistically attempt. Nobody knows for certain why the work stopped. It could have been that transport capacity was exceeded. It could be that the stone cracked during the final stages of quarrying. It could reflect a scaled-back building plan, a shift in imperial priorities, or funding and political changes that interrupted construction before these blocks could be processed. What we do know is that the attempt happened. The channel cuts run along its sides. The wedge slots sit along its base. The tool marks of the workers who tried to free it from the bedrock are still legible, after 1900 years, and then, for reasons lost to us, they simply stopped and walked away. This is really the heart of what makes Baalbek so extraordinary, and it is also the answer the title of this video is pointing toward. No single human, and no modern crane, can lift that 1,650-ton stone, and in that narrow sense, the mystery is real. But the new answer is not that ancient people lacked the ability to build something like this, and it is not that some unknown civilization, or non-human intelligence, did the work instead. The new answer, confirmed by nearly 2 decades of careful joint archaeological research between German and Lebanese teams, is that thousands of ordinary Roman-era workers, using iron tools, wooden wedges, water, log rollers, rope, and coordinated human muscle, pushed their engineering right up to its absolute limit. They succeeded spectacularly with the trilithon, 3 800-ton stones that still sit exactly where they were placed, in a wall so precisely fitted that in places you still cannot slide a knife blade between the blocks. And then they attempted something even larger, and this time, they failed, or at least they never finished. Both outcomes are preserved side by side in the same quarry, a complete record of ancient engineering pushed to the very edge of what was humanly possible in that era, with both the triumph and the limitation left in plain sight for anyone willing to look closely. None of this requires lost civilizations, forgotten super-technologies, or visitors from beyond our planet, and it is worth being clear about why those explanations do not hold up once you actually look at the evidence. If the megalithic platform predated Roman construction, we would expect to see weathering patterns on those stones that differ from the Roman work built on top of them. We do not. We would expect the tool marks on the giant blocks to look different from documented Roman quarrying technique. They do not, they match precisely. We would expect some pre-Roman written record referencing an existing megalithic structure, a Phoenician inscription, a Canaanite text, some early traveler's account describing a monument that was already ancient by classical times. There is none. And we would expect the masonry style and stone-fitting techniques of the giant blocks to differ meaningfully from the smaller, unambiguously Roman stones nearby. Instead, the same polygonal and orthogonal fitting techniques appear throughout. Every piece of physical evidence points in the same direction, and every working archaeologist who has studied the site in the modern era, including the senior researchers from the German Archaeological Institute, has reached the same conclusion. This was Roman work, from start to finish. What makes Baalbek worth telling this story about is not that it proves ancient people had secret advanced technology, and it is not that it proves some kind of unexplainable mystery beyond human understanding either. It proves something a little more grounded and honestly more impressive, that a state with enough organizational capacity, enough skilled labor, and enough patience could take basic tools, ropes, wood, water, and human coordination, and use them to accomplish something that still challenges our modern engineering models to fully explain. The genuine open question sitting at Baalbek today is not who built it. That question has a documented, well-evidenced answer. The genuine open question is the fine-grained mechanical detail of exactly how they pulled it off, the precise sequencing of the ropes and capstans, the exact composition of the transport road, the specific ramp design used for the final lift. Engineers and archaeologists are still working through experimental models trying to nail down those details, and that work is ongoing right now. The trilithon is still sitting in that podium wall today, exactly where Roman workers placed it roughly 1900 years ago. The stone of the pregnant woman is still half buried in the quarry, along with its 2 enormous companions, one of them among the largest single carved stones any human being has ever produced. The tool marks are still visible on all of them. The inscriptions naming the Roman colony are still part of the historical record. The Bronze Age layers are still there beneath the temple foundations, a reminder that this valley was sacred ground long before Rome ever arrived. Nothing about that story needs an alternative explanation to be remarkable. It is remarkable exactly as it stands. A valley in Lebanon where you can walk from a temple built at the outer limit of ancient engineering capability to a quarry just a few hundred meters away, where